Alright, hey everyone, welcome back to the LangChain by Project series. I'm Mukul from NIIT. Now, if you've been following along, you'll know that in the last few episodes, we've been gradually building things up, moving from simple chains to routing and then to more structured multi-prompt logic. But in this episode, we cross a very important boundary. Because until now, our AI models were mostly just talking. They could respond intelligently, but they couldn't really take action or interact with anything outside the conversation. Today, we're building an AI conversation debugger with tools. A system where the model can still chat naturally, but can also decide when to call real tools, and where everything, memory, tool usage, and final responses, is fully visible and debuggable. And just like the rest of the series, everything runs fully locally. We're using Llama 3 through Ollama, LangChain LCEL for orchestration, and Streamlit for the interface, which means no API keys, no cloud calls, nothing. Alright, let's walk through the code and see how this actually works. We start right at the top with the usual imports. We bring in Streamlit for the UI, the platform module so we can read system level information, and a few typing utilities to keep our functions clean and readable. From LangChain, we import ChatOllama so we can talk to our local Llama model, along with chat prompt template and MessagesPlaceholder so the model can understand conversation history. We also import the message types: human message, a message, tool message, and base message, which LangChain uses internally to track who said what. This becomes important later because we'll actually inspect those messages ourselves. Finally, we bring in the tool decorator, which is what lets us expose Python functions directly to the model. Next, we define our model name as Llama 3.2 3b and configure the Streamlit page with a clear title and a wide layout. Now we get to the first major idea of this episode: tools. We define two simple tools. The first is a calculator tool. It takes a math expression as text, evaluates it, and returns the result. If something goes wrong, it safely returns an error instead of crashing the app. That matters because tools should be deterministic. They should always behave in predictable ways. The second tool is system info. This one returns basic runtime information, like the operating system and the Python version. Again, nothing complicated, but very deliberate. We're teaching the model an important rule. You can talk freely, but when something requires hard facts or deterministic logic, you call a tool. Once both tools are defined, we collect them into a list and pass them into the model. Next, we initialize ChatOllama. We pass in the model name, set the temperature to 0.4 so references stay calm and consistent, and then bind the tools to the model. This single step is what makes the LLM tool aware. From this point on, the model can decide whether it should answer directly or call a tool instead. We also keep a simple string output parser ready, although in this episode, the focus is less on parsing text and more on understanding message flow. Now we define the prompt. We use a chat prompt template with three parts. First, a system message that clearly explains how the assistant should behave. Be helpful, use tools when they are useful, and stay transparent. Second, a messages placeholder called history, which injects the full conversation history into every new interaction. And finally, the human input itself. We then connect this prompt directly to the large language model using LCEL. No unnecessary abstractions and no deeply nested chains, just a clean, readable flow. From there, we move into memory handling. All messages are stored inside Streamlit's session state under a messages key. That means every human message, AI response, and tool output is preserved across interactions. We also define two small helper functions. One appends new messages to memory, and the other trims memory to the last n conversational turns. This gives us precise control over how much context the model sees, which becomes especially powerful when debugging or replaying conversations. This leads us to the core of the episode, tool execution logic. We define a function called runChain. The user input and the existing conversation history are sent into the chain. If the model decides to call a tool, LangChain returns tool calls as part of the response. We loop through those calls, identify the correct Python function, invoke it with the given arguments, and store the result as a tool message. Once the tool has run, we call the model again and provide it with the tool output so it can generate the final response. The flow is completely explicit. The human sends a message, the model decides, the tool executes, and the model responds using the tool's result. Nothing hidden and nothing inferred. If no tool is needed, the model simply responds as usual. Either way, we always end up with a clean, traceable set of messages that gets added back into memory. Next, we look at the sidebar, which acts as a debug panel. There's a slider that controls how many past conversation turns are used when replaying memory, along with a clear memory button that wipes everything instantly. This is extremely useful when testing behavior because most issues in AI systems tend to show up in memory handling. At the bottom of the sidebar, there's a simple reminder. Tools are deterministic, and the LLM decides when to use them. That one sentence alone explains a large part of modern agent design. In the main interface, we render the chat. Every message in memory is displayed based on its type. Human messages appear as user inputs. AI messages appear as assistant responses, and tool messages are shown clearly so you can see exactly when the system stepped outside the model. A standard chat input lets you ask natural questions, perform calculations, or request system information. Each message runs through the same pipeline. Tools are invoked when needed, memory updates, and the final response is displayed. Finally, we get to the memory inspector. This shows exactly how many messages are currently stored and lets you expand a raw view of memory to inspect every message object, human, assistant, and tool. There's also a replay option that trims memory to the last n turns and asks the model to summarize the conversation using only that limited context. This makes memory visible, controllable, and testable, which is something most AI demos completely hide. So that's episode 9. We didn't build a flashy or gimmicky agent. We built a debuggable, tool-aware conversational system, an AI that can talk, remember, decide when to use tools, and show you precisely how it's doing all of that. This pattern becomes the foundation for everything that comes next, from agents and retrieval systems to tool chains and multi-step reasoning. If this episode helped you understand how tools actually fit into LangChain, not just conceptually but architecturally, make sure to like the video, subscribe to the series, and let me know what you want to build next. Thanks for watching, and I'll see you in the next episode.